Prime factorization. So when we're talking about finding the prime factorization of a number, what we're really talking about is breaking it down using multiplication until we can't break it down any further. So when I see 36, I say to myself, what times what is 36? And you can use any numbers you want so long as they multiply to be 36. So I'll use 4 times 9 because 4 times 9 is 36. Now I have to ask myself, with these numbers, can 4 be broken down further? Yes, it can. 4 is 2 times 2. But 2 is a prime number, and my prime numbers I circle. 9 can also be broken down further. It's 3 times 3. And 3 is also a prime number. So my prime factorization is 2 times 2 times 3 times 3. Now with numbers that are large, like 1,980, we're going to have to kind of use our thinking abilities to break these down. And a lot of times we wind up using the divisibility rules. So I look at this number and I say to myself, well, it ends in a 0, which means it's divisible by 10. So I know it's 10 times something, and it has to be 10 times 198, because our rule for multiplying by a power of 10 says that you just add a 0 to the back of the number. So if we add a 0 to the back of 198, we get 1,980. Well, 10 and 198 are both even numbers, so we're going to be able to break them down. So 10 is going to be 2 times 5. 2 is prime, and 5 is prime. 198 is also going to be 2 times something. And so what I do is I say, well, half of 100 is 50. Half of 90 is 45. And half of 8 is 4. So now we add these up, and we're going to get 0 plus 5 plus 4 is 9. And 5 plus 4 is 9. So it's 2 times 99. Our 2 is prime, but 99 is not. It's 9 times 11. Once again, 11 is prime, but 9 is not. It's 3 times 3. So we've fully broken down this number, and now what we want to do is write all of the factors in order from smallest to largest. So let's count our 2's first. So I've got 2 times 2 times, I don't have any more 2's, so 3 times 3 times, don't have any more 3's, but I have a 5 times 11. And that's all of my prime factors. So 1,980 can be broken down into 2 times 2 times 3 times 3 times 5 times 11. Our last example is 693. Well, it's not even, so it's not going to be 2 times something. It doesn't end in 0 or 5, so it's not going to be 5 times something. So let me try my divisibility rule for 3. If I go off to the side, 6 plus 9 plus 3. Well, 6 plus 9, that's going to give me 15. And 15 plus 3 is 18. Is 18 divisible by 3? Yes, because 3 times 6 is 18. So that's telling me that 693 is going to be 3 times something. Alright, well let's kind of break it down. 3 times something will give me 600. And 3 times 2 is 6, so 3 times 200 is 600. And then 3 times something will give me my 90. And that's 3 times 30 will give me 90. And then 3 times something has to give me my 3. And that's 3 times 1. So let's see, if I add up all of my pieces, it's 200 plus 30 plus 1, or 231. Well, my 3 is prime. 231, I have to figure out whether that's prime or not. And I might as well just use my divisibility rule for 3 again. So I do 2 plus 3 plus 1. 2 plus 3 is 5, plus 1 is 6. And I'm asking myself, is 6 divisible by 3? Yes, because it's 3 times 2 is 6. So 231 can be written as 3 times something. Alright, so we're going to have to use a little bit more thought here, because if I try to break it down the way I did 693, 3 times nothing is 200. So let's just think to myself, okay, so I want 3 times something that's very close to 231. Well, let's see here. How about 3 times 60, right? Because 3 times 6 is 18. So 3 times 60 is 180. And that would leave me with what left over? Let's see here. We're going to have 40 left over. No, 41, right? If we have 231, we'll have 51 left over, because we've got 20 to get to 200 and then 31 more. So 51. Okay, so I have 51 left. Well, I could certainly say that 3 times, let's say 10, would get me my 30. Alright, so 180 and 30, that's going to give me a 0, a 1, carry the 1, and 2. That would give me 210. So I need 21 more to get from 210 to 231. And 3 times 7 is 21. So now I add these up. And 60 plus 10 is 70, plus 7 is 77. My 3 is prime, but 7's not. It's 7 times 11. And 7 and 11 are both prime. So when I see 633, I know that it is 3 times 3 times 7 times 11.